I am so pleased and honored to be presenting our panel of keynote speakers today, who will be sharing their perspectives and experiences on emerging synergies of AI and learning health systems. As biomedical knowledge undergoes rapid changes in its production, format, and dissemination, and in many ways due to AI, it's critical to know that AI models are forms of computable biomedical knowledge. And so with that, I'm excited to hear from our keynote presenters for this year's meeting. They'll be discussing their experiences and perspectives on how AI is impacting CBK in their institutions and takeaways perhaps more broadly. Each presenter is a health informatics leader in their own right and is at the forefront of conceptualizing and applying AI for learning health systems. We'll first be hearing from Dr. David Dorr, who is Oregon Health and Science University's Chief Research Information Officer and a Doctor of Internal Medicine in Portland, Oregon. His interests lie in collaborative care, chronic disease management, quality, patient safety, and what clinical information systems require to support these areas. Dr. Dorr has worked on longitudinal care management systems, which are holistic, patient-centered plans for patients, particularly for older adults and people with chronic conditions. And finally, at OHSU, Dave is helping lead AI governance efforts there to establish intake processes for health AI and setting strategy. Our second panelist will be Dr. Julia Adler-Milstein, who is a professor of medicine and the inaugural chief of the Division of Clinical Informatics and Digital Transformation at UCSF in San Francisco, California. Holding a PhD in health policy from Harvard, Dr. Adler-Milstein is a leading researcher in health IT policy with a specific focus on EHRs and interoperability. And recently, she launched a new initiative between her division at UCSF Health to develop an innovative platform and process for ongoing monitoring of AI tools deployed in the health system. And thirdly, we'll be hearing from Dr. Abel Coe, who is a professor of medicine and preventive medicine in the Feinberg School of Medicine at Northwestern University in Chicago, Illinois. And he's the founding director of the Center for Health Information Partnerships. Dr. Coe has led nationally recognized projects, including the ONC-funded Chicago Health IT Regional Extension Center, the Chicago Area Patient-Centered Outcomes Research Network, or Capricorn, and several large ARC-funded QI, quality improvement initiatives. Abel currently directs the Institute for Artificial Intelligence in Medicine, shaping the vision for the Institute and how it can enhance healthcare at Feinberg and beyond. So with that, let me hand the reins over to Dr. Dorr. Dave, you want to take it away?
Great, thanks so much. This is an absolutely amazing panel, and I feel like I'm the least of them, so I'm going to just try and set up this topic a little bit for the group. I'm going to share my slides briefly, and we'll go this. So I'm just going to talk briefly about this. I think I am only going first because here at Oregon Health and Science University, we're explicitly trying to figure out how to address this topic. And I'll start by saying that, one of the amazing things about artificial intelligence, especially the new large language models, the generative AI models, is its apparent ability to summarize, I guess I would say, large amounts of information, including knowledge. And even though it has no ability really to it's only predicting what should come next. It does have sort of an amazing ability to transform our how we handle computable knowledge, and we'll talk a little bit about that in this talk. So just a disclosure, I received funding from a bunch of places. And when we talk about AI, it's got a weird space with the FDA in that they say there's a lot of AI as potentially medical devices. Most of what I talk about doesn't have this. So a little bit about this. So I think the one thing I wanted to start with is that there's no better time for trying to transform healthcare than right now, except for maybe yesterday. And that's because costs, especially in the US, are going up, but outcomes are worsening significantly. All the while, we're sort of producing more and more knowledge about what could work, right? And these new capabilities that we'll be talking about potentially could address this, but only if they're in a system. And so I know that most of you know a lot about learning health system work. It wasn't the topic solely of this meeting, of this group, but I like this reference set where we're sort of bringing together elements of a system, science, informatics, incentives, and culture to align them for continuous improvement. So obviously knowledge that's generated both through this process and elsewhere needs to incorporate in this. For us at OHSU, Paul Allen's our Chief Data Officer. We really are thinking about driving these constant cycles, like most people would, um, to really bring more innovations into care, as well as learning from our data. And this is really important in a much better way. We see this as a major gap, that our ability to really drive innovation and bring new knowledge and our understanding of where the gaps are in care is limited. Lots of benefits, as you know, from this. But for us, what really was transformative is as new capabilities from machine learning came into being, we started to get an increasing sense that this could absolutely transform what we do. Obviously, generative AI is only one part of machine learning. There's many other applications, and we also felt like multimodal data AI was coming as well. So we actually were thinking that for radiology and pathology at some point, and dermatology, other imaging-based specialties, as well as others, not doing this was a serious risk, and not leveraging the capabilities of some nascent algorithms in the next 5 or 10 years would really leave our system behind, that there were knowledge embedded basically in these algorithms that they needed, not just for efficiency, but also for understanding. And so for us, we basically set up an AI governance committee, um, and we identified sort of the major areas that we thought were going to be transformative in this for us as a system. And this included everything from ambient life, that I like to call it now, like where you're recording different aspects of care and then automatically sort of extracting or summarizing that information, where AI systems are responding in different ways. We're doing a lot of transcription and translation. But really for us, the crucial thing, I think, was, boy, we thought we could extract concepts and then from unstructured information, from the literature, from our notes, from all the data that we have, and then we could put that into structured systems to then drive the learning health system. We could also identify and prioritize the most important things about a patient or a need through summarization, and really get through what has been such a challenge in this area, which is really deciding what is important, what matters most, not just from knowledge itself, but from care teams' perspective, and especially patient perspective. And so this is a big lift, and we're working on it in a lot of ways. We see substantial potential for improvement here, and that this is really as a system disruptor is just incredible, including a lot of efficiencies to be gained, but also in terms of health outcome improvements. And so our question, and this includes the easiest implementation of some of these tools that I've ever seen, including for our EHR here overall. But there are incredible numbers of problems here, right? That there are new kinds of biases and errors in these tools. So even as we're sort of thinking about implementing them to do this incredible work, we really struggled with that. And our biggest issue is inconsistency and the problems of automation bias. So inconsistency here is a study where we use something to summarize information and transform it into a note in a standard set of of cases through AI scribes, and we found incredible inconsistency and the need to sort of look out in a whole different way. So really, as we're thinking about this transformation, worried about that aspect. The other, and I think this is crucial, is when these systems are wrong, they're usually wrong very confidently. And the less training and experience you have in overall, you tend to believe them more, which we call automation bias. It's a form of confirmation bias. Basically, they look so good that we think that they're problematic. And if you're trying to deliver a form of knowledge, in this case, like a breast cancer risk score, that then you'll need to act on, that can be a serious problem, right? You don't stop yourself. So you're not able to detect those errors very successfully. So for us, what we're doing at OHSU is establishing the Center for AI-enabled learning health science. So like learning health system work, but incorporating AI and the need to leverage AI in every aspect. And the reasons are very straightforward. Basically, we see this as disruptive. We want to make it a positive disruption and really leverage these opportunities. And so this is the time to sort of drive this. And I think it will really help an incredible amount to really bring people together. There's so much excitement about some of these uses, about reducing burnout and improving, the way we do our work. That it's also a great opportunity to engage this. There's so much we think you can do, but we really have to do it thoughtfully and safely. And my favorite thing now is to sit down with residents and we talk about a problem that we're seeing. We look at the data, and then we try and like synthesize the knowledge about this area using one of the very common tools for generative AI that do literature reviews. And it's really amazing how quickly you can go through a cycle together. So for what's different for us is, we're really thinking about incorporating AI into our knowledge syntheses processes and pulling that together. We're thinking about, probably you can't see the edge of the slide here, the using AI in our innovation. So a lot of the learning health system projects we've thought about use IT anyhow, the EHR, combining it with the sociological changes that we need for change. And now we're saying we could do even more of this because of some of the opportunities. And then again, leveraging AI's incredible ability to sort of summarize and extract concepts from data by incorporating into that process. So for us, we think this is an incredible opportunity and sort of matches really well with learning health system needs. I think there's a number of issues overall. I won't go into this, but we have sort of this learning health system model cross mission that we're using in it. So I'll finish here. I think I'm right at the end of my time because the next two, Julia and Abel, really have some interesting thoughts to share about this. But when we think about this, when I think about the cores that we're setting up for this center, I think, knowledge extraction and implementation of that knowledge, the ability to translate that into action is so amazing with these tools. But we have this problem where we can't always predict their inconsistency, and we need to build those layers and testing to understand how we deal with that. Similarly, like getting better data through concept extraction from data and from narratives, from unstructured data, from all kinds is going to be really transformative. But then the question is, what do we do with that? How do we put that, leverage that data and the gaps in performance we see to address that? And then this new implementation paradigm, we could do so much more now by applying these models and feeding them text in some ways that we can do a lot of work now, but we're still going to have the same sociological and cultural issues. And we need to think about the future for building to multimodal data AI. And then for innovation, I think we've struggled as a system to really understand how we do this. But build innovation into our processes, a crucial part of a learning health system. But the AI, there's enthusiasm. People want to try it. We see people building tools all the time, actually, with some of these. But it really requires us rethinking how we do these evaluations, how we get rigorous, robust, pragmatic approaches to this. So I'll just finish with that and pass it along to the next panelist. Thanks so much for the time.
Great. Thank you so much, David. I will say that when I saw your slide deck, I felt like I was glimpsing the future. And it was so, exciting to see, what a health system that is really thinking about like AI and learning health system coming together looks like. My talk will tell you about our experience at UCSF, which is, I would not describe as forward-looking as where they are at OHSU, but is work that is sort of, I'd say, unfolding as we speak. And is perhaps the more typical experience of where at least academic medical centers may be, where we have a bunch of AI governance work, we have a bunch of learning health system work, and we're kind of trying to figure out how to put them together to work well. So my talk is really going to be focused on sharing what that experience has looked like. Again, with the caveat that like this is all happening now, so you're going to get to see a little bit of the guts of the process, but also a bit about, I think, where we are headed with this exciting coming together. So my talk today is going to be about, as I said, bringing together our AI governance work and our learning health system work at UCSF. This talk is a combination of ideas that I have led as someone who has for a long time been interested in studying the impact of technology tools in real-world clinical settings, and AI is just sort of the next version of those tools. And Mark Pletcher, who is the head of our Department of Epi and Biostat, who has really been one of the leaders on our learning health system work, and Sarah Murray, who's our Chief Health AI Officer. And again, the fact that the three of us are now talking about what this future state looks like, I think is really representative of the fact that these ideas are starting to come together. So just really briefly, trying to put together, where we have been coming into this moment of trying to put these pieces together. I think our journey to learning health system work has been, again, perhaps typical of many academic medical centers where we believe in the concept of being a learning health system, but trying to figure out how to build the infrastructure and culture and and funding and all the pieces that this group knows need to come together to do that. And so the result is a bit of fragmentation where we have learning health system efforts that really live within the health system itself, and this continuous improvement group run by Ralph Gonzalez that again uses a very lean management-based approach to do learning health system work within the health system. And then the desire to create a space for the research community to do embedded research in the health system. And so over time, we have awarded grants and infrastructure support for our researchers who want to do health system embedded studies. And so again, I think there's been some capacity to do that work. But what we a year ago, ish, maybe not even 6 months ago, the head of our CTSA and one of our senior leaders in our health system said, okay, let's do another reboot and really think about some of the capacity that we need to do this work at the next level of scale. And so we invited Chuck out, to come and indoctrinate us in the science of learning health system development. And we literally yesterday sent our task force recommendation report to our senior leaders that really argues for some key investment in some of the infrastructure we've been missing, like building learning communities within our health system and trying to improve some of the technical infrastructure to do our LHS work. So we're hoping that in the coming years, obviously depending on availability of funding, that we'll be able to really move into an integrated model where the researchers and the health system leaders who are doing LHS work can come together in a community formation and work together to solve problems. So again, still very much on the learning health system journey. But one of the pieces that I think has come out of the learning health system work is the ability to do sort of EHR embedded interventions. And we have, I think, a fairly robust model now for a researcher that wants to implement an EHR embedded research study and to approach it sort of through a learning health system framework. And so this is, we call this our APEX enabled research, it's just the name of our EHR here. But you can basically bring a research idea in to this like central group that will consult and help you both think about the technical piece, but also how do you approach this so that you're sure you're really learning what you want to learn? And in some cases, then that allows the researcher to, get a letter of support that goes in with their grant and get the funding, and then come back and actually sort of do the build of the tool. But again, with a lot of the support from our Learning Health System Governance Committee that can help ensure that the learning objectives are met. So that can be support from like a biostatistician and others. So again, we've tried to sort of enable this EHR embedded research. It includes, like, for example, a randomization tool so that we can try to generate the best possible evidence from these studies. So that's sort of what came out of our learning health system work, which was like some funding and structure for projects and some specific infrastructure to be able to embed these studies within sort of the EHR and EHR related projects. So then separately from that, we have been evolving our AI governance framework because, as again, I suspect everyone who works in a health system knows, there is now just a huge number of possible tools that could be implemented. And so what has to happen is a decision about, like, do these tools solve the problems that our health system considers high priority? And then are these tools trustworthy? And so the way that we have structured AI governance is basically there is one committee that is the people who understand the problem space and have the budget to solve problems within the health system. We call them our Health AI Steering Committee. And they prioritize the AI tools that there are going to be resources to implement. And then basically, once they've identified a sort of set of tools, like AI Scribe is an example of a recently prioritized and resourced tools, then it gets bumped down to our Health AI Oversight Committee that does all the work to assess the trustworthiness of the tool. And we use the HHS domains of trustworthiness, we measures, we do, retrospective, prospective, pilot, sort of a full set of reviews of all the tools to ensure they meet our trustworthiness criteria. And then, as you can see, sort of as the tools get evaluated, they get bumped up to Health AI Steering when we have to make the next decision about resourcing and scaling. And so this process, I'd say, is now, again, just over the past year or so, up and running, and allows us to have this pipeline of AI tools that we can both prioritize because they meet important needs. And also we have this rigorous process to ensure the trustworthiness of the tools so we don't put into place anything that is unsafe or otherwise problematic. So again, we've had these sort of two different infrastructures that have been built up. And now is the moment that we sort of see that they are coming together, because we realize that a lot of what we've built in AI governance is very similar to what we want to do on the learning health system side, where we're learning about not just the trustworthiness of the tool, but also the impact of it. So as we sort of step back and try to put these two together, what we're realizing is that these AI tools are trying to improve many aspects of care delivery, many of which have been the focus of our learning health system efforts in the past. And so if we're going to really sort of shift focus to AI tools as the source of innovation and learning, for every tool, we want to be sure that we're asking the question, like, does it work? Does it actually improve the outcomes that we think it's going to improve? Are there unintended consequences? And how can we refine them to work better? Again, these are just core LHS questions that we would ask about learning about anything, but just now the focus is really on the AI tools that we're bringing into the health system. So what we're trying to do as we learn is to ensure that we're learning about all the aspects that might be relevant. And there's sort of this temptation to think about, this is like magical thinking, that those of us in this field know for a long time, right, that like it's the technology that has the impact. And so just sort of turn on the AI tool and then assess if outcomes get better. And that's, again, just developing the, the AI algorithm itself is a huge amount of scientific work. And we have an incredible group of computer scientists, data scientists, biostatisticians, et cetera, that are focusing on creating good AI algorithms. But the learning needs to extend beyond that framework. So actually, we need to then think about how do you build around that just core AI tool, clinical insight, so that we understand like where and when that new information is needed, the human-centered design, the informatics, the implementation science that actually takes an algorithm and turns it into a useful tool. So now we have this much broader notion of, of what we need to understand and study for each of our AI tools to ensure, again, that that they're effective and that we're learning about how to do each of these well. And I'll just say that I think that this has been like really our Achilles heel, is that each project we like try to figure out, okay, well, what is the clinical problem we're really solving here? What is the best user interface design? And we're not doing that work as scientifically and systematically as we need to. It's like we reinvent it with each project that we do. So that's sort of been is how do we really focus learning in this broader set of areas around the tool? And then another area that, again, I've been really passionate about is it's like all of these tools have a behavioral model. They think like if we give this clinician this piece of information, they will take a different action. And that different action is what's going to lead to the improved outcome. And so we should be measuring those actions because to really learn about whether a tool is working or not, it's really critical to see if that interim action was impacted in order to then understand whether we're seeing the change in outcome or not. And again, those of you who know my work have been very passionate about, EHR metadata as a way to measure clinician actions. We actually have a lot of data that allow us to create good measures of how clinicians are interacting with information in the EHR. So I think we have a huge opportunity to study these actions. And so again, that's this broader set of experts who we want to bring to the table to really look at this full pipeline. So again, I think, in the past, we might have just focused on output accuracy, predictiveness, algorithmic performance, truth versus hallucination. And we really want to shift to, those are important, but to also looking at measuring how our users are interacting with the tool, what actions they take. Again, I think that there's just so much opportunity for learning there that's going to allow us to then make sure that these AI tools are really leading to the value that we hope that they will. So yeah, and then of course the downstream outcomes too. So again, that's where I hope this is all going, bringing together the breadth of scientists that will allow us to do the learning along that whole pipeline. And so to do that, and this is my final slide, again, I think we just need experts and knowledge resources in this broader set of spaces. We need to figure out how to characterize the problem space and the outcome measures. I think we've always recognized and done that well, but how do we build up the sort of study science measures, et cetera, around these questions of user engagement or measuring user interface design? And so again, as this field matures and we think about where the MCBK infrastructure can be developed, I hope that it will be around capturing the knowledge around these key pieces so that we can really learn about this full pipeline. So I will leave it there for my comments and pass it along to Abel.
Great. Thank you very much. Thank you, Josh and Chuck, for this opportunity, and also to David and Julia for their leading comments. Let me see if I can get these slides to be shared. Okay. And there we are. Okay, so I am not going to talk about governance because I think Julia and David already did a really excellent job. Instead, I'm going to talk about what we see based on some recent experiments is the future of AI in the data to knowledge process. And that's looking forward like 1 to 3 years. So I just have 2 industry disclosures and here they are. So, okay. But when we think of the future, sometimes we look to the past for some inspiration. And so this map is a map that sort of captures some of the medieval trade
Hi,
routes.
Abel.
Yeah,
Hi,
yes.
so sorry to interrupt. This is Josh. Just if you're moving your slides forward, we're not seeing them flip.
Oh,
We're
no.
still on your title slide.
Oh, no. Okay, that's a
Yeah,
problem.
and we don't see the presentation mode if that's what you're intending.
That is what I'm intending.
Okay.
So
So
hold on. Let me try something else. Hold on. That's unfortunate. Let me try something. Okay. Can you see my disclosures at all?
no, we still see the how does AI
Okay.
fit in a fair future, and it's in your non-presentation mode. So
Okay.
there's
All right.
disclosures. Now we see it.
Okay. Sorry about that.
No worries. Yeah, I don't know if you can just hit like the
Okay.
slide presentation button, say maybe from current slide or something from beginning
Yeah. Let's
in
see.
your toolbar.
Can you see a map showing up?
I see it in the as an upcoming slide on the left-hand side.
Oh boy. Actually, I did share a slide with Noor too. If she'd like to maybe we'll just go with that, and I'll just skip sharing my slides at all. Is that all right?
Yeah,
Maybe she
just give
can.
me a moment to pull those up.
Okay, let me just stop sharing. Yeah, I
Wonderful.
did have this funny little thing. It said, a web version today, so that's maybe that's part of it.
I know this is just all part of your larger plan to build suspense. So it's
I mean,
successfully done. Nicely done.
Let's see if this works.
Here
Okay.
we go.
Yeah, and Noor, so maybe you can just go to the disclosures. I'm just gonna prompt you like the old school way, like with the slide things. So okay, so next slide. Great. Okay, thank you. I'm gonna keep going. So when we think of the future, near future, sometimes we look to the past, I think, for inspiration. And this map is a map of Mediterranean trade routes during medieval times. And at that time, oftentimes these traders had to conduct business across multiple different environments, different languages, different native languages, different cultures. And so they developed what came to be known as the lingua franca, which everybody in informatics has heard before. I needed to find out more. So lingua franca is the language or tongue of the Franks, basically referred to this sort of pidgin language that, was used to conduct trade. It was a spoken language, not a written language. And, didn't have a huge number of words, probably like a couple hundred words. So, but very effective for conducting the business of trade at that time. So next slide. I'm going to argue that the data to knowledge is fundamentally a translation problem. And I'm going to just go ahead and click through all the, I click until everybody has a box on there. So if you think about today, a lot of the knowledge we use is an electronic health record. It starts from a patient. The patient tells you, the clinician, when you're in clinic, what they are experiencing. The clinician then goes ahead and types in their note and they say, okay, this person I think has type 2 diabetes, or they might code that a little bit. The clinician researcher then says, I'm going to define diabetes as like these series of codes and these series of criterion. And then the informatician goes ahead and takes that and converts that into more complex sort of terminology standards. And this is oftentimes how we think of, the data to knowledge sort of process. Next slide, please. It is really a very laborious process. And this is just an example from Chicago. So today, like at Northwestern Medicine, we go ahead and we get data on electronic health records. We put that into a data warehouse. And then every night or every year or every quarter, we then create these different data marks, these different subsets, oftentimes with terminology standards mapped into them, data model made into them. And then if you click the next slide, I think it'll advance it. One more, I think. What we then do is we generate all of these different individuals have to handle these data somewhere along the way. And so it's a very, energy intensive process. And if you imagine you running a network across multiple institutions, then you have lots and lots of people involved in this whole process. I mean, we've come to realize how costly that is when we try to run these networks across the whole city of Chicago. Next slide. Along the way, we've had to develop our own lingua franca. And so in informatics, we use that term all the time because we say, oh, you know what? I need to have a terminology standard that basically defines like laboratory tests or diagnoses codes. So across all of these, we've developed, a whole bunch of different terminologies and ontologies to go along with that. So, again, these are something that we all have learned to come and, know and love. I myself am a huge fan of terminologies. And so what I'm going to go ahead and tell you next is going to probably like not be consistent with being in love with terminologies. So next slide. So you can put it twice more. So, terminology, remember the original lingua franca was only like a couple hundred words. And now with terminology, we want to capture nuance for every possible scenario that's out there. And the issue is that that's kind of like, there can be a very, very long tail because the reality of what people experience is always going to be, exceptionally diverse. And are we going to keep on creating new codes for every single time that we have a new condition or new diagnosis or a new particular sort of like observable concept that we want to see? So, you think about ICD codes, there's, a whole bunch, 60,000 or whatever. You think about SNOMED, there's, a couple 100,000. This is going to be, in many ways, almost like an unsustainable long game process. And again, I'm a big fan of terminologies. Don't get me wrong. I just think that there's some limitations there. Next slide. So what we see instead is that like there may be a potential with AI tools to go from like more of a human expert driven approach to defining medical concepts and capturing them and making them reusable and interoperable to one that may be more machine learning or purely data derived. Now it's not going to be perfect, but this is, I'll show a couple experiments that sort of tell us which way we think this is going to go. So next slide. So as we've heard, LLMs are kind of these amazing things. They're really good for capturing sort of human language. They do that by creating these tokens, and then you take words, and you can have this attention span. And what it essentially does is creates these multi-dimensional representations of these words. And in capturing the word relationships one to another, it almost infers a type of knowledge. It infers a type of relationship that, in essence, captures. Like when we speak, we're trying to express a thought. It captures those thoughts and may even capture sort of subtle relationships that we, even in speaking these words out or writing them out, we don't capture. So this dimensionality is really huge now. It's like 1,500 dimensions and growing for a lot of these large language models. Next slide. Now, what we've seen in the literature in the past couple of years is something pretty exciting, which is that if you take electronic health record data, and this was a great article in 2021, and you model it like words or sentences, in these multidimensional sort of representations, what you end up being able to do is create sort of like these multidimensional clouds, like that one up on the upper right corner there. And if you then further take that and cluster it down, all the things that sort of fit together, next slide, what you can then identify is that there are it can pick out clinical conditions, things that we as clinicians recognize, or researchers we recognize, and it can do so oftentimes better than the old rules-based approach. And this is sort of a comparison against some of the phenotypes, computable phenotypes we built in Emerge or now stored in this PKB sort of knowledge base that Vanderbilt supports. And so again, as you look across the performance, this sort of data-driven approach to identifying medical concepts, or in this case, diagnoses or phenotypes, it outperforms, a typical expert-based approach. So next slide. We've been running these same experiments locally for the past 2 years. And what we've seen is that when we do the same thing, and this is taking just structured data, not the notes, we take structured data and run it and create these multidimensional representations, and then cluster those together. Next slide. We did a couple experiments. So this is one that compares on the right 4 clinicians, and then a large language model taking structured data from electronic health records. The terminologies, diagnoses, codes, all the terminology we mentioned before, clustering together for a group of patients and trying to see what it thought was going on. And what you find is that where it's all green, there's pretty consistent sort of like identification of the concept, the medical concept, across clinicians and the machine. In some instances, there's very poor agreement, and we see this pretty consistently. But for the majority of common conditions, we can actually get pretty tight agreement between what a clinician thinks and the LLM thinks. in terms of defining a clinical condition. So next slide. This experiment was run using just notes. So just, EHR embedded notes. And this was against intensive care unit patients and trying to figure out, could an LLM pick out a number of common conditions in an ICU setting? And then how did it compare against attending physicians? So pulmonary critical care trained physicians. And what we saw again was that with just notes, free text notes, an out of the box LLM, zero shot, could identify with incredibly high precision recall common conditions. Now, on certain conditions, I think the immune-related sort of immunoglobulin deficiency, it didn't do so well. So again, for the majority of it does really well. For rare conditions, not so well. So next slide. Now, compound that. So it used to be that as clinicians, we would go ahead and type our notes in electronic health records. We have this sort of, clinician listening, and we think about it, and we'd say, oh, this person probably has this, and this, and this. For the past 2 years, we've been using an ambient AI tool, in this case, the DAX Copilot tool. I think my clinic was one of the first ones to adopt it. And I will say it's certainly improved. I think there was initially some issues. It's gotten so much better, so much so that, next slide, if you look at the usage, I think we have a couple hundred physicians using it now in our system. The cow's out of the barn. 100% of the physicians that have been using it want to keep using it. Now, I just want to point out that in clinical medicine, physicians don't agree on anything. There's never a situation where we agree on 100% everything. But so while there's going to be problems, and there are issues, there is no way clinicians are going back to writing notes again by text, by typing. The cow is out of the barn. This is going to happen. So what that means is that data is entering into the electronic health record, not through a person, but it's being automatically captured in essentially a multi-dimensional embedding. And that has become the new grist that we're going to be using for purposes of future data to knowledge transformation. Next slide, and then I'll finish. So again, my argument is going to be that while we have traditionally done things a certain way with translation between multiple people all along the way, I think the near future is going to look very different. So if you want to click one more slide. I think what's going to end up happening, and once more, is that, in fact, a lot of this translation step that happened that required in the past, like informatics infrastructure and a lingua franca of these terminology standards that we've had to develop and maintain, a lot of that can be replaced. And then it turns out maybe for the near future, the lingua franca of data to knowledge is back to essentially human language. And so human language is going to become likely the majority of the lingua franca for data to knowledge transfer. So with that, I'll stop and be happy to sort of take questions along with my other panelists.
Wow. And Dave, Julia, Abel, I'm just blown away. Thank you so much for these fantastic talks. And we have a good amount of time here to field some questions and engage some reactions from our audience members. And for those folks, please do feel free to capture any questions in the chat, and we'll direct your questions to our panelists. But if I might take the opportunity to field a question myself first, just to get things rolling. I'm blown away by all of what you've covered. Dave talking about training the humans, for example, Julia, governance, and Abel, what the implications are for AI as we move data into knowledge. And so I'm thinking that fundamentally under all this, it's going to require fundamental organizational change and culture. And I was wondering if that's something that you've been thinking about or encountering as you've underwent your work, and where you see organizational culture having to change or will be changing as a result of some of these new interventions and technologies that are underway.
I could start a little bit on this. I think Abel actually really was hitting at this. So I mentioned what I call our ambient life, which is sort of where he was talking about you get recorded and then all this data comes out and the AI is sort of working with that in a completely different way. And what I see, some of the initial tools we're looking at understanding how to use safely and well, as really impacting a culture right now that is just full of burnout and sort of low change energy, feel like things can't get better to some extent. I mean, it's really tough, but when you use some of these tools and we can implement them, people are very excited. And so one of our AI strategies, and I think the strategy for the center comes from some work by Christine Sinsky and others about bringing back joy in work. And so I think a lot of our engagement strategy is to focus in there about really saying, how can we leverage these tools and this kind of transformation ability to change our culture to one where people are excited about engaging in transformation, see these tools with their, their failings as ways to really directly impact culture uh, overall. And that's the hope, I'll say, but I do think that there's an opportunity for that.
Yeah, I mean, for me, I feel like I see the culture most acutely in what I think of as like the level of evidence needed to feel satisfied that something has been achieved. And like in our health system, they just don't need like what researchers think of as gold standard or even silver standard evidence. And so just like as we bring our worlds together, it's just this constant tension between like the researchers who are like, we should do this in a randomized way, and the more operational people who are like, that just sounds really complex and like it will take longer. And, so I know that this is not a new issue. It's certainly not specific to AI, but it's like, this is the conversation that keeps playing out over and over again. And I think is really at like the heart of being able to like bring these worlds together in a way that I think we could really learn about our AI tools in a rigorous way, but also in a way that sort of is moving at the speed of the tools and the perceived need, right? We can't say, oh, well, we'll tell you about AI Scribe 2 years from now once we've done, the full perfect gold standard randomized control trial. Like we just would not be acceptable. So from my perspective, that is still just like the crux of this culture issue. And we, I think, have to convince our health system colleagues that we can like move learning at the speed of sort of their need for decision making and moving forward.
Yeah, I would. Yeah, I think that's absolutely right. And culture takes longer to change. I think, and processes are changing so rapidly right now. I think you're asking the right question, though, Josh. I think we do have to keep a very close eye on how it evolves. But I think when there are going to be some of this technology, I think is so transformative that as I said, I don't think we can put it back, and it's going to keep moving no matter what. And I think it's just more about how do we put in appropriate sort of like safeguards and continue to monitor and observe it so that we can sort of catch those as those changes sort of might have to take a sour turn. So.
Well, thanks so much. I want to call out to Noor and others on the team who have been monitoring what looks to be a very active chat space. And I didn't know if there are any particular questions that have surfaced that you would like to raise to the panel.
Yeah, so I have seen that at least Julia and David have responded to a few of the comments that are in the chat. That's available for everyone to see, but I'll bring up a question that Blackford posed about, I guess, worrying about the Ouroboros effect, how AI is increasingly causing homogenized inputs created by AI itself. And he linked I think, an article on that. So just wondering if Abel had any comments on that.
Yeah, Blackford, thanks for that. Good to see you. I saw you. No, I think that's always going to be a concern. I think there's certain segments of where health or healthcare is that it's more of a risk. I think on the ambient side, I'm less concerned about because the source of information. It's not like a snake eating its tail. There's a person involved. There's people involved in generating the information. The patient still is sort of the raw source, and I think that part's good. But I do have worries about other places. So like for example, even like like insurance processes. We see like sort of like arms race with health systems and the payers have an AI agent and the health system tries. And so you do have this weird situation potentially happening where, one person's generating AI content, the other person's ingesting it with AI and vice versa. And so there's going to be certain segments of this healthcare system where it could become a real issue. I do think it means, though, that the people that generate content, just like you would in like sort of the social media world, have a tremendous amount of value, because new content, new human content, real content is going to be really much more valuable than ever. So one thing that we should put in place, and I think I've seen a system like UCSD do this really well, is ensuring that there is transparency when you are creating things with AI. So I think if that is in place, then that will also help. But I would say that actually, this puts the value back in the hands of people that are generating a novel content.
Great, thanks. And then I see a question from Jerry Oshoff for all panelists. The overarching context for all the great work discussed is how money flows in healthcare, and this is undergoing huge shifts with the new U.S. federal administration. Would love to hear speaker thoughts about specific ways the mechanisms discussed are or will be applied to address intensifying drivers around costs, etc.
Yeah, I'm happy to share again. I feel like I'm like my answers are very practical. But like at our health AI steering committee, like the CEO of our health system basically said, like, show me which AI tools are going to allow us to sort of like deliver the same or more healthcare without adding people. And I just think like that like that's where health systems are, is like, if we're going to invest in these AI tools, like we need them to improve efficiency in some way, because that most directly impacts the bottom line. And I think, there will be some capacity, I hope, for other more innovative tools, or where we need to study, their impact, because we don't know what the benefits are. But I mean, I think we and others are just starting with the areas where, we think there will be like real tangible, bottom line improvements from the use of these tools. And so that, again, that's just directly comes from cuts, from how things are funded. I mean, I think obviously if there's like massive cuts in Medicaid and, others, like there will be a further retrenching, and to figure out whether there's even sort of capacity to experiment with new tools. But, I think fundamentally, if we can swap out expensive human labor with less expensive AI tools, like there will be appetite for that, I think, sort of no matter what the future looks like.
Yeah, I'm not an economist, but I would say I always find it interesting how marketplaces always match like the need. So like we all recall when electronic health records rolled out, their price point was coincidentally the same as the incentives that were put out there. And we see the same thing with some of the, ambient AI tools. Initially people didn't know how to price it. And then as you sort of get experience with it and try to measure how much time savings it has, et cetera, you can start developing a much more clear value proposition to the health system. And then the prices oftentimes will sort of like somehow gravitate towards where that is. So I do worry if prices work exactly like they should, then ultimately the savings doesn't really get back to the health system. But right now I think there's still a lot of flux in how much those things should cost. So.
I'm seeing that we have a hand raised, and maybe we could try out a question from the audience directly from Todd.
Thank you, everybody. Really appreciate the panel. Yeah, I put a question in chat, but I thought I would just articulate it, now. And it has to do with what Abel was just saying about this, sort of snake eating the tail effect of AI. In general, one of my concerns is, like, I think, Abel, you gave the example of that there was some ICD coding of data maybe that had AI in the pipeline. And so, even if it's human reviewed later, right, there's some, place where we have data, and now all of a sudden all the data about a patient is associated with that condition, right or wrong, right? And we're kind of growing that data set. And then the next model trains on that and learns about, from all the mistakes and whatever. And I get it. You said, well, right now the pipeline is there's humans in it. But as David Dorr said, AI is confidently wrong. When it gets something wrong, it sounds authoritative. It sounds like it knows. It sounds like it actually used data to form this fiction it just created. So my kind of question about all of that was, because I feel like we're in the early days of LLM and we're just going to end up building a huge amount of questionable data while the models are in their infancy. Should we be tagging this in some way? And is there any sort of effort to tag this data as AI generated? What sort of parameters were used? Was it a low temperature setting, high temperature, this kind of, acceptability of made up, data? Should we tag what's been human curated? I don't know if there are efforts to do this, but I feel like we run a risk of creating a bunch of bad data early.
Yeah, it is early days. I think you're absolutely right, Todd, and that's the right question. I do think there's actually a lot of work and attention to this particular issue because there is so much concern about it. As I mentioned, I think UCSD is the one I think that I saw lead the best in terms of setting a precedent around this. That if something is generated, then the patient should know that. And so it actually says, like when you look at your note, it says this was generated by AI, and so that sometimes prompts people to be more careful and go back in it. I still have to review all my notes, and I didn't show some of the egregious early examples of how it went totally off the rails. But certainly on the imaging side and some of the work we've been doing, all the models we do, we also will include like a separate process that then says, okay, what were the segments of the image that upon which you made these conclusions, and what was the it's still, even with that, it's hard to figure out. You're sort of like, I don't know what it saw here, but at least it's a start. And so I think those early efforts, where this proliferation of these new tools and this exuberance, I think it does have to be managed with additional like tools to sort of then, like you said, traverse back to like the provenance of how it came about. So I think that I think has, but I think this is the natural course of a lot of technology implementations. It starts out with everyone just goes bonkers, and then someone eventually has to bring it back in little by little. So yeah, I think that's absolutely right.
Yeah, I guess I agree with Abel. That was a very good summary. We actually participated in an ARPA-H call, submitted an application called Precise AI that is explicitly trying to address some of this. Like, how do you do that? Like, how do you benchmark? If you're generating new information, how do you, on which your future AI models will be trained? How do you understand degradation? And a lot of this is really interesting in that the proposals are to run sort of regular benchmarking exercises to see how the models are performing and to where the answers are known, right? And to understand like what's happening there, as well as reach, carefully training healthcare teams and the kinds of errors they're likely to see and what those come from. The thing that I really liked is the uncertainty quantification part of it, where basically like you use some of those tools to say, hey, this model is wrong this amount of time. And this is a use case where it turns out it's wrong more often than not for these reasons. And so you start to, use these tools more carefully. I heard you talk a lot about generating data, right? So generative AI, things that are generating new information. And that I think is exactly right, that some of the generated information the models do tend to degrade over time if it's just consuming its own information. And so you could see that happening over time. There are ways to address that. It's part of learning about how to deal with these new kinds of models. But it is something that I think you have to look out for. So a lot of what we're doing is saying what is the, quality assurance and algorithmic monitoring ecosystem we need to have, and where does that need to live in health systems which can't do most of this actually, and where can that be in other places, and then really understand how to deal with degradation. I think that's really important. I still think human curation will be crucial.
I don't know, Julia, if you have thoughts, comments you want to share. Otherwise, we can go over to Chuck, who has his hand up.
Never want to steal the floor from Chuck, so.
I'll just
Chuck.
say thank you for answering. I appreciate it.
Thank you, Todd. Great question. Chuck, over to you.
Oh, you're on
You're
mute,
on
I
mute.
think.
I saw that too. Okay, I just see we only have a couple of minutes left, so I want to put a yes or no question to each member of the panel. With the growth and advent of large language models, is there a future for goal-directed AI, or where a model is developed to solve a particular problem or answer a specific question, or is the tsunami of large language models going to run over approaches to build models aimed specifically to solve focused problems? Yes or no?
Yes, there will be goal-directed AI. Absolutely.
Yes.
Yeah, I think I'm also a yes, but I think my biggest curiosity is when we will also see what I describe as sort of system level AI, where like an AI tool that can see the entire system and the trade-offs and sort of really, you know, kind of manage it as a system level rather than at a goal and individual decision level. And so how those two things will interact, I think, is like a fascinating, will be a fascinating evolution to watch, because that's what I don't know.
Thank you.
All right. Just looking through the chat, I see that Philip Walker had asked a question about in an ideal LHS, wouldn't we be able to utilize RWE or RWD to bridge that tension between researchers and operations?
Yeah, I mean, I think, yeah, I mean, I'm not sure if this was to my point, but, you know, I mean, again, I think real world evidence is, you know, it is not, it doesn't just like magically get created, right? There's still like a process of evidence generation. And I think it's the approach and timeline of that you know, that creates some of the friction. I mean, I do think there are examples of where like monitoring and surveillance systems have been set up using real world data. And so I think in those cases, yes, like that it does allow some of the bridging. But you know, again, I think it's when there's sort of an initial problem space that's been scoped, and then the question is, how do we bring real world evidence to understand that problem scope, right? Like that whole process, if done with like a true research lens, usually moves at a pace that like those whose, you know, job it is to solve that problem from an operational perspective usually find to be too slow.
Yeah, this is an interesting construct. So we do think about getting these virtuous learning cycles together to generate real world evidence in our work. I think my caveat to it always is only in certain areas where you can really define these inputs and the changes well, does it work for me? Like there's just so much enthusiasm about this, and we end up sort of failing dramatically when the sort of quality of the data itself or the questions being asked, the evidence that we're trying to generate from this through the real world, right? Just is an ill fit, and that's the main problem that I've seen, where the sort of art of this comes in, it really constraining it to the areas where you think it can work the best, and avoiding asking the wrong questions of it, and that's the gap I've seen most frequently.
We are, nor are there any other questions that are in the chat that that we could ask and put in front of our panelists?
Yeah, I think people are still inputting comments and questions, and I see that some questions are getting answered in the chat as we go along. Christian asked, and I'm not exactly sure what it's referring to, but he or she asked, how does it work exactly? What information needs to be disclosed? And is it through the patient or physician? What does the LLM create or generate?
I wonder if that's an add-on to Todd's question about tagging the knowledge and having subsequent models learning from what previous models had generated and the data that go with it. Christian, feel free to make any corrections to that, or if our panelists have an answer, and I apologize if I'm doing a poor job at at framing it for us. Christian, if you could maybe provide a little bit more context or clarification in the chat, that would be great. If I might just take one question myself here to pose to our panelists. I'm curious about your observations on what's going on in the external environment in knowledge and access to knowledge. And as we know, things are rapidly changing, particularly around the federal level. So thinking about changes in federal funding that could impact access to data and knowledge. And what advice do you have for folks in terms of being agile in the face of these rapid changes underway, and how might you be having to adjust to kind of a very fluid situation at the moment?
Yeah, this is something we're all facing. So there's a couple things that I think about in terms of knowledge and data. So the interesting part about, really being towards the end of the information age, going into a new age, is there's a lot of places to get these data, and a lot of the data are, but they're not curated, right? They're not trusted. And really, this issue about trust in our data and in the knowledge is an incredibly crucial one. And that's true of algorithms for AI, right? So that's some of the questions I've heard right now. It's something that we use to evaluate these tools pretty thoroughly, to look for concerns about trust, the problems, but also like the sentiment around trust, really focusing first on our patients. Um, and so given, these changes, it's interesting. I just saw this survey, what people still trust in terms of from the medical profession and the information. There's actually quite a lot of sentiment that continues about, really wanting the best evidence-based treatments, the knowledge. And so to some extent, what I think about here is, how do we get these, maintain a well-trusted and well-curated set of data in some cases, and knowledge in a lot of it, and recommendations, given some changes and move away from sort of that evidence-based into more sentiment-based. Ultimately, I don't have an easy answer for this. There's some great efforts going on, but this idea, I think the main idea that I have is like, really the opportunity here is to really think about what can be most trusted and how do you build that trust up amongst different stakeholders, and then really leverage that. And that's something we're working very hard on.
Yeah, Josh, I think we're all like very thrown off today. I don't worry at all about AI, to be honest. I worry about really dumb humans right now. Like that's what I worry about most, and I worry about the removal of existing human knowledge. I think that's the part that's very very worrisome. as you all know, like we have a lot of data sets that we all rely upon, and there are only certain entities that can manage those or maintain those. The states oftentimes are the raw source for a lot of those, and so I think I think many of us are certainly thinking about how do we make sure that there's always going to be access to the real world data sets that I think that's the part that is really a concern right now for me. But again, it has nothing to do with any of this. It's just more like you asked about what we're concerned about. That's what I'm concerned about.
Question from the chat from Marina is, do you see standards like FHIR and SNOMED CT contributing to the quality of data used by AI in its possible analysis of real world data?
So I guess I'm the one maybe who was pushing the, so I was doing this partly to be provocative, but I will double down a little bit and say that terminology standards and some of the HL7 standards, like they were developed around use cases, and they are still going to be very valuable because there are going to be certain vertical use cases for which you're going to want a human readable and expressible or a particular computable function that you're going to have to take underlying. Let's say you have like complex AI generated multi-dimensional representations. You're still going to have to create like outputs of that either a person understands or a compute function can input and take in a consistent enough fashion. So I can imagine that there's going to be like surface representations of this underlying complex data that again are tailored for particular use cases. So yes, there's always going to be a need for that. And as I mentioned, there are particular areas where AI today has real problems, complex syndromic conditions, things that are, rare or unusual, edge cases, that kind of stuff. So we're still going to have that sort of those funnel points that express things in ways that are understandable to a particular user.
Yeah, I guess for me, these will continue, FHIR specifically will continue to be very useful. It's just an information exchange standard. And we've tried to do, non-FHIR based information exchange we have for a long time, and it just lacks the context and the ability to understand both what is requested and what needs to be sent. And so AI, as it acts on those kinds of tools, it's just a helpful guidance. I think for specific terminologies, when they're used properly, which is not always for sure, they try to say something more precise in some ways than just general language. And I often think about this for how we deal with transforming a set of concepts from, say, SNOMED to plain language, right? Which is how a lot of the generative AI works. And we might take a whole group of those codes and then say they all mean diabetes, for instance, to use Abel's answer. And the curation of those value sets can be difficult, and the how those codes got entered in the first place is a real problem. But they can carry a level of precision that really our language frequently misses by focusing on the individual codes. If you focus on the individual codes. And so AI could benefit if that precision is accurate in almost all cases. I would say what it does so well is be able to traverse that hierarchy of precision, I think, by providing something that is easier for people to understand more quickly. The risk of that is it's totally incorrect because it's based on the errors that we all put into that data in the first place. But I do think those tools will still be used. Those standards will be very useful.
I'm happy to address the question about some of the ethical issues that we've come across, if that sounds good. Again, I think it's been really interesting to see the sharp end of this, like what are the specific, issues that we've seen in our AI governance work. I mean, I think one is transparency, especially when we're buying a tool from a third party, and there's just limits to sort of how transparent they're willing to be. So if we think it is the best tool, but that vendor is not willing to be fully transparent, do we then say we're not going to pick the best tool? So I think that's one issue. Obviously, a second one has been like where we see variable performance in the AI tool across, different subpopulations. And so again, we've then had to have discussions around, well, if we see that a tool isn't performing as well for, for certain populations, like, is that okay as long as it's better than current state? So basically everyone is going to get a benefit from that tool, even if we're going to accept that some of the benefits might be differential. So I think that's been another conversation, is again, what does it mean for a tool to be equitable? And so that's, I think, been an interesting ethical discussion. And then the third example I'll give is we are considering AI tools for things like which claims denials to fight, which is, again, like, feels like it has, all sorts of ethical issues on it just by the nature of the tool. And then you sort of have to unpack all of the, like, well, what is current state? Like, what happens when a claim does get denied? Do we actually ask the patient to pay or not? And if we ask them to pay, is it balance bill or is it, cost-based? So anyway, I just find that these conversations like have this fascinating unpacking that happens with them. And you really have to understand current state, I think, to be able to assess the ethical issues and understand whether that tool really has the potential to be unethical or not. And again, it turns out at UCSF, like, we actually very rarely ask patients to pay. Mostly we just, pick up the cost. And so that tool proved to be, I think, much less problematic than we thought coming in, where it sounded like, oh my gosh, this has the potential to be a horribly unethical tool. Anyways, these discussions have been some of the most fun of my career. So for those of you who have the opportunity to get involved in AI governance, I actually highly recommend it, because it's a fascinating frontier.
Oh, this has been fantastic. I see we're at time, and I think it's a great place to end things. What a fantastic panel. Thank you all so much for joining us today and sharing your experiences and perspectives and the challenges that you've been facing in this really exciting space.